Okay, what we're working with today is performing function operations. And so there's four basic operations that you do in math. You're going to add, subtract, multiply, and divide. And we have to actually do these with these functions. So my first problem I have is I have an f function that's 3x plus 4, and then I have a g function that's 5 plus x. And so the first thing we have to do is we have to find the sum of them. So I'm actually going to do f of x plus g of x. So f of x is 3x plus 4. That's the first function. And I need to add my second function, g of x. And all I'm doing is I'm adding, so really I'm just combining my like terms. 3x can go with a 1x, which makes 4x. 4 can go with a 5, which makes 9. And that's my answer. Thank you. So the only time domain is an issue, we can write this, is really if you're taking the root of something. If you're not taking the root of anything, or if you're not dividing, the domain is going to be all reals because all numbers will work. Okay, when we get to some, you'll see what I'm talking about. But the time you have to focus on the domain is when you're taking a root or when you are dividing. All right, so the next problem is different. So I'm going to take my f function, which is 3x plus 4, and I need to minus my g function, which is 5 plus x. I think what people will make the biggest mistake here is that they will forget to distribute the negative. So it's going to be 3x plus 4 minus 5 minus x. And so now when I combine my terms, a 3x and a negative 1x is a 2x. And 4 minus 5 is a negative 1. And so the difference of those two functions is 2x minus 1. And any number I plug in will work. And so this is an all reals. All right, for the next problem, I have to find the product, which is multiplying. So I'm going to do 3x plus 4 times 5 plus x. And so when you multiply, you can use FOIL, you can use our square that we've done, or you could distribute. I just like to distribute. So 3x times 5 is 15x. 3x times x is x squared. I've distributed 3x to everything, so now I need to distribute the 4. 4 times 5 is 20. And 4 times x is 4x. Now we need to combine our terms. Our biggest exponent is that should be a 3x squared. It's 3x squared, so that's first. Then I have a 15x and a 4x, which makes a 19x, and then my 20. So the product of the f and g function is this whole thing. And any number I plug in for my x's will work, so this is an all reals. All right, the last one we have to do for this is dividing. So I'm going to take my f function, which is 3x plus 4, and divide it by my g function, which is 5 plus x. There's nothing that I can reduce or do anything, so that's my answer, which is nice. The only issue is that when you dividing, you're never allowed to divide by 0. Can't divide by 0. So we have to figure out how would this be 0. So we take the denominator and set it equal to 0. And so to get rid of a positive 5, I would subtract it. So that means I can't have negative 5. Because if I have a negative 5, 5 plus negative 5 is 0, and you can't divide by 0. And so my domain is everything except negative 5. So this is why I mean over here by the domain, when you divide, you usually are going to have something that it can't be. And for this one, it can't be negative 5. All right, why don't you try the second set doing the same thing? The first box you're adding, subtracting, and then multiplying and dividing. And then check your work to see how you did. So when you think you're ready, press play. So you should have done f of x, which is x squared plus 3 plus x minus 4. And if my x squared is the only thing that can go with that. The only thing that can go with x is x. But this is what can actually combine a 3 and a negative 4, which is a negative 1. So when I add those two, I get x squared plus x minus 1. This is a regular problem. There's not a radical and there's not a dividing. So my domain is all reals. So let's go to the next one, subtracting. It's going to be x squared plus 3 minus x minus 4. Remember to distribute the negative, and it becomes negative x plus 4. And then I can bring down the x squared plus 3. X squared can only go with x squared. X can only go with x, but now it's become a negative x because I was subtracting. And now I have a 3 and a positive 4, which is a positive 7. And this one is also all reals. All right, the next one, multiplying. It's going to be x squared plus 3 times x minus 4. And I'm just going to FOIL or distribute. X squared times x is x to the third. X squared times the negative 4 is a negative 4x squared. 3 times x is a positive 3x. And 3 times negative 4 is a negative 12. Nothing is like terms, so that's my answer. And because I don't have any radicals and because I'm not dividing, my domain is all reals. All right, so let's go to the last one where I have to divide. And so it is x squared plus 3 and x minus 4. I can't reduce these because in order for me to cross something out, it has to be an x minus 4. And so this is my answer because there's nothing to reduce. But remember, the denominator cannot equal 0. So then maybe that's a better way to write it here, is that it can't equal 0. So that's why it can't be 5. And so if I add 4 to both sides, it's letting me know that my denominator cannot be 4. Because 4 minus 4 is 0. And you may not have a 0 on the bottom of a fraction. All right, let's do one example on the left, and it's going to have another part to it because you're also going to have to plug some stuff in. So go ahead and start off by copying this down. And then we're going to find the sum, the difference, the product, and the quotient. Then we're going to evaluate it if x is 25. And then we're also going to find the domain. So there's a lot of different parts to this one problem. So f of x is 2x. And g of x is negative 3x to the 1/2. Really, this is just the square root of x. So we're just going to write it like that instead. These are not like terms, so they're done. They just go here. And so now if I'm going to evaluate it, I'm going to plug in 25. So 2 times 25 plus negative 3 times the square root of 25. So this is 50 minus 3 times 5, because the square root of 25 is 5. So it's 50 minus 15, which is 35. And then the last thing I need to do is find my domain. And remember I said domain has to deal with radicals or dividing. Well, we finally have a radical here. And so our domain, we can't take square roots of negatives. So that means it has to be from 0 or higher. So it's greater than or equal to 0. All right, over here, you're going to subtract. So it's the exact same thing, but you're minusing. And so you change your signs, and it becomes plus. And so there's my first answer. Okay, so now that we have what our difference is, now we're going to plug in 25. So it'll be 2 times 25 plus 3 square root of 25, which is 50 plus 3 times 5, which is 65. So there's the next answer. And then our domain, it's the same idea as when we found the sum. You can't take the square root of a negative. So your domain is anything greater than 0. All right, so multiplying f of x is 2x. And I'm going to multiply it by my negative 3 square root of x. Well, 2x is on the outside because there is no radical, and negative 3 is on the outside of the radical. So 2 times negative 3 is negative 6x, square root of x. And there's that answer for the product. Now again, we have to plug in 25, so it's negative 6 times 25 times the square root of 25. 6 times 25 is 150, so it's negative 150 times 5. So it's negative 750. And then it's the exact same idea where we can't take the radical of a negative. So our domain, again, is x is greater than or equal to 0. All right, last one we have to do is we have to divide. So it's going to be 2x over negative 3 square root of x. And the only issue here is you can't have a radical on the bottom, so I need another radical x. Thank you. And so these together become x squared, and the square root of x squared is 3, or is x. But now I have an issue because I have x's on top and bottom. So now my actual answer is 2 square root of x over negative 3. And then here, I'm going to plug in my 25. So 2 square root 25 over negative 3 is 2 times 5 divided by negative 3, which is negative 10 over 3. And then the last thing, I don't have anything on the bottom, but I do have a radical. And here, x just has to be greater than or equal to 0. So remember, when you're adding or subtracting, you just add your like terms. And when you subtract, make sure that you distribute the negative. And then the only time that there's going to be issues with domain is when you have radicals or when you're dividing. And those are the domains that will not be all reals.